The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listeners radio, and now we return you to your host.
Ladies and gentlemen, welcome back to another edition of Cosmic Catastrophe on Revolution.radio. I am your host, Diamond, from the Oppenheimer Ranch Project. My lovely co-host, Leah Shaper's joining us today.
Hello.
Welcome to the show. For those of you out here, we're going to be talking about some interesting topics. The title of today's program is Cosmology in Crisis. We're going to be discussing the Redshift Blunder, the fact that the universe is now twice the age as of last week, 26.7 billion years old now, and a study that claims to remove human bias from the dinosaur debate is actually filled with human bias. Who could have thought?
The irony.
What are your thoughts on the show?
Well, I think as usual, we're kind of pointing out very simplistic mistakes that are being made in science. And I don't know, personally, I find it really mind-boggling that some of these really basic errors are being made and no one is picking up on it or is willing to talk about it. It's bizarre.
Well, let's first talk about the term consensus that's being used in science. This has been thrown around for decades now. The 97% consensus that all scientists believe that humans cause climate change. That is total garbage. In fact, it's a very low number. The problem is using the word consensus. There is no consensus in science. As soon as there is a consensus, the science stops.
Yeah. Yes. If you start writing papers to fit a particular consensual theory, then you're not doing science.
And that's kind of what's been happening for decades, if not almost 100 years in cosmology. They came up with some agreed upon standard model, and no one is willing to change it in any way because it has to stay exactly the way it was.
Yeah, it's really bizarre. And so then you get, one consensual theory upon which everything else is based. And so then it just becomes this comedy of errors after that.
And we're going to be talking about the comedy of errors. Can you see the screen?
Yes, I can.
The first question, is the universe infinite? It's a good question because using constraining mechanisms in mathematics and the standard model, the universe can't be infinite. So that's the biggest problem. The standard model doesn't allow for an infinite universe because we're currently using Big Bang cosmology, which, by the way, is like a story invented by a friar in the 1500s that was part of the Christian church, I believe.
We can talk about this later, but there's a specific reference as well in one of these papers that I think we're going to discuss about who sort of came up with this. It's like a cosmic egg idea.
Yeah. We are definitely going to dive into the Redshift Blunder that has been obstructing cosmology for over a century. And we're going to try to get you to understand why measuring redshifts isn't enough to understand the universe at all.
Yes.
And the evidence against redshift as a kind of Doppler effect was the fact that recently we discovered that quasars were coming out of the center of galaxies that had different redshifts than from the galaxies. So so that was the problem. You're looking at the same thing, but it has a different redshift at the same spot. So clearly using redshift to explain anything becomes a huge problem when what it's showing you is not what you're assuming it's showing you.
Right.
Yeah.
And the biggest problem here, right, is it's the confusion between the idea of the Doppler effect, which really should only apply to sound waves, and redshift. Two different phenomena, but we're treating them as if they're the same.
Yeah. Now, to actually dive into this topic, you have to learn about cosmological redshift. how redshift is determined. You also have to know about gravitational redshift, the idea of tired light, the idea of intrinsic redshift, the idea of infinity, and on and on. So the problem, I think, is that most cosmologists just listen to a soundbite, assume that what they're using is correct, and then they go from that.
Well, and then this is also what's taught in textbooks, right? I mean, this is what I learned in college in studying physics is you learn about a lot of these concepts, but this paper that you're showing right now, the Redshift Blunder has been obstructing cosmology for over a century, written by David Rowland. This is a great guide to what the mistake is with the way that we're treating redshift.
David Rowland's a personal friend of mine.
Oh, I didn't know that.
Different David Rowland, but.
Oh, nice try.
Now, let me just quick read the abstract and
Sure.
I'll get your comments.
Sure.
As light travels extreme distances through space, its frequency slowly diminishes. It's called attenuation. We observe this phenomenon as a redshift. The tendency of visible light to drop towards the red end of the spectrum is the redshift. Unfortunately, for over 100 years, redshift has been misinterpreted as a Doppler effect. Thus, it is the fundamental cosmological error that creates the fatal flaw in these misconceived hypotheses, including Big Bang theory, expansion theory, Hubble's law, dark matter, dark energy, all the things that we really can't explain. And some of the funny things that you and I were talking about, like how some of these cosmological constants aren't even constant, right, making it even further a farce. Now, this study explains the true nature of redshift and provides a formula for estimating the rate at which light attenuates over distances. When redshift is properly understood, it can tell us how far light travels before it drops beneath the visible spectrum.
Right.
Now, this is interesting because you and I were talking about how if this didn't happen, this attenuation, when the sun set, the entire night sky would be filled with a blazing light that would be blinding.
Yeah, no, and that's one of the things that's pointed out in this paper that just is very convenient for us as humans. That so with the distance away that a light source is, the frequency decreases and the wavelength increases, which is how you get redshift. Increased wavelengths head towards the red spectrum. But at a certain point, if something is far enough away and its initial frequency is, make sure I don't have this backwards, is low enough, eventually it's going to drop below the red spectrum into a light that we cannot perceive. So what that means is that there's lots of stars that we're not seeing basically because they're too far away. Like we can't detect them at all because they're below the visible wavelength of light. So if that were not the case, then the entire sky would be lit up every night. There would be no darkness, right?
Yeah, exactly. And that leads into a deeper conversation about what's going on in the last decade in cosmology. We've created newer and newer satellites that can see further and further. Mm-hmm. And when we looked out at the edge of what we thought was the edge of the universe, unfortunately, it wasn't the edge of the universe. It looks like the rest of the universe. And a lot of cosmologists were scared, they were confused, and they were wondering what is going on. Well, the obvious answer is that your standard model is incorrect. Right. Because if you're looking at the edge of your Big Bang universe and you're seeing the same stuff that's at the center of it, then your model is probably completely wrong.
Right. And here's how we got here. I mean, this blunder with redshift is a huge part of the problem, right? So if you have, let's say, two different stars, the same distance away, but they have different frequencies of light. Well, as the light travels to you and things go into redshift, well, one of those stars may enter the red spectrum, but another one may remain in the blue spectrum because its initial frequency was so much higher than the other star. So we're using redshift in a way to determine the distance that stars are away from us, but we're not accounting for their initial frequency when we do that because we don't know what they are. So how can we actually gauge the distance of these stars and therefore the size of and age of the universe if we don't know what those initial frequencies are? So we're completely using redshift in an incorrect way. And so that's given us this idea that there's like an edge to the universe, when that may be completely incorrect. I believe it's completely incorrect because it doesn't make any sense, right? When we talk about the edge of the universe is space and time. So if there's an edge, well, what's on the other side of the edge if there's no more space and time? That's impossible. It doesn't make any sense.
It might be the DMT space.
Yeah, it might be. I mean, one of the things that's really interesting to me too about this is that I used to very much buy into a lot of the ideas of Western cosmology, and sometimes there's some interesting parallels in the Eastern philosophical world, and sometimes those parallels kind of involve these weird paradoxes. And so you get into this place where there's a paradox, and you're like, oh, well, that's the secret information. It's in the paradox, and we as humans just can't quite wrap our brains around it. But that's not a way to gauge the validity of a theory whatsoever. I mean, it seems really interesting, but it still doesn't make sense.
Yeah, and so do you know how they solved the problem, which is called the impossible early galaxy problem? Now, for those of you listening and watching later tonight on Magnetic Reversal News at 8 p.m. on our YouTube channel, the impossible early galaxy problem occurred when James Webb Space Telescope first peered at the so-called edge of the universe and saw what appeared to be galaxies that were just as developed as the center of the universe. And so guess what the standard cosmological people did? They just doubled the age of the universe to allow for those universes they're seeing to exist. It's
right, they just changed the math.
Bad science.
Yeah, no, I mean, and this is like, I want to read something from, this is an article that is about this paper that just came out, right? So the new paper, is it new? Yeah. This was accepted in July of
July 7th, 2023. Here's the paper.
Right. Okay. So, and this is JWST, which is the
James Webb Space Telescope.
Thank you. I was struggling with my words there. Early JWST, early universe observations, and ACDM cosmology. So this is an article that's written about this paper. By the way, it's kind of really funny that this paper, right from the beginning, starts with like a whole gobbledygook of acronyms. So if you're not, when doesn't define what those acronyms are, which is just really bad writing, but it guarantees that if you're not in the field, you're going to have a really hard time reading this paper.
Yeah, it's Lambda, CDM, TL, CMB, CCC, and on. Like what?
Right. I mean, I will say, I mean, to be fair, it is obviously like geared towards people in the field, right? Because most of the paper are the equations that they're using to come to these conclusions. But okay, so in an article that is written about this paper, and there's a lot of articles about it because everybody went, "Oh my God, the universe is twice as old as we originally thought," you know. And this is hilarious. So Gupta, who's the author of this paper, the main author, Gupta introduces the idea of evolving coupling constants as hypothesized by Paul Dirac. Coupling constants are fundamental physical constants that govern the interactions between particles. So we see this all the time in physics equations. We have certain variables that represent a constant in the world. For example, C for the speed of light, or G for gravity, which is kind of a whole other conversation, right? Because we've discovered that gravity is not constant, actually. But so then it says, according to Dirac, these constants might have varied over time. It's a constant. For it to vary is an oxymoron. Okay, but maybe the structure of the universe has changed a lot over time, so maybe the constant has to evolve.
Yes, if it was Big Bang universe, then the constant would probably evolve.
Right, but again, like, you know, this is an oxymoron. It doesn't make sense. So later it also says that Gupta proposes a constant that accounts for the evolution of the coupling constants. So now we have constants that are not actually constant, and because they're changing, we need another constant to account for them. Like, come on, what are we doing here? This is ridiculous. And this is what happens when you have a theory that is based on one blunder and then you build everything else on top of it, right? Like this idea that redshift is the same as Doppler. This is a mistake that was made in 1915 by the astronomer Vesto Slipher. I don't even know. And ever since then, we've been treating light like the Doppler effect when in reality, light waves and sound waves propagate in completely different ways. So why are we doing that? It's just ridiculous. It's absolutely ridiculous. And it's funny how having personally gone through the university university system and learning physics this way, and you kind of just buy all of this stuff all along the way. Now, granted, for me, this was a little bit difficult because I was studying philosophy of science at the same time. So I'm doing the science, and I'm also trying to evaluate the validity of the science at the same time. So I actually really had a very hard time with my physics program because of that, but for good reason, because the way that we're doing this, we're just building on errors from over a decade ago. It's crazy. And this very simple paper, by the way, to all of our listeners and viewers, this paper about the Redshift Blunder by David Rowland, I totally recommend reading this. It's pretty easy for the layman to read, and it does a great job of explaining why this is a mistake and the mistakes that have resulted from it.
And this paper will be linked below the video in the description box, so it'll be easy to find. Now back to the discussion on the James Webb Space Telescope and the problems. Now the problem was, well, let's just go here to the beginning of the paper here. Observations with the James Webb Space Telescope revealed the existence of massive, bright galaxies at the very edge of the universe. Now that statement is, first of all, based on no factual evidence.
Yeah, it's based on
every single person is taught this, that there's an edge of the universe.
Yeah.
So the very first sentence isn't really that scientific.
Yeah. Well, and the other thing that I think is interesting too is that there's all different models for a contained finite universe, but never do we actually consider the infinite universe.
Which might answer all the questions and probably does.
And probably fix the math too.
Yeah, and we've got lots of people that know about plasma cosmology, the electric universe model, and other models that aren't part of standard cosmology that answer many of the questions that leave these scientists baffled. So what do they do? It says here, a small fraction of its current age estimate of 13.7 billion years, according to the standard model, apparently is impossible based on what they saw. So this is actual science. When they made a telescope that could see the so-called edge of the universe, and what they looked at wasn't what was supposed to be there, that means their model is flawed. They need to go back to the beginning, and they still haven't done that.
Instead they just scrambled and they said, oh, well, let's change the math, and it must be much bigger and older than we thought.
So they just pushed the edge of the universe out to where it needs to be. Ironically enough, to a point at which is probably impossible to see ever with any technology.
Yes.
Because of all the problems with the propagation of light and the distances we're talking about.
Yeah. Well, and then the hilarious thing, right, is that this means that probably what's going to happen is we're going to build another more powerful telescope, and we're going to look for the edge of the universe again. And guess what? We're probably not going to find it. It'll be the same situation as this, just on repeat. And then they'll say, oh, well, actually, the universe is, 4 times as old as we thought.
Yeah, and they developed hybrid models that included the tired light concept in the expanding universe. Like it's so constrained, their ideas of what they're using. The whole expanding universe idea, when people actually started to look into it, what they found was that there are almost an equal number of objects that are coming towards us as are moving away from us. And that wouldn't be possible in the expanding idea.
Yeah, but I wonder too, because I think that that's also flawed. Like one of the points that David Rowland mentions is that because we also talk about blue shift, right? So that the idea is that objects that are moving away from us should blue shift. but that's actually not true. There's no such thing as blue shift. If an object appears blue, it has to do with its initial frequency and the distance away from us it is, and it's just arriving at us as still blue. That's all it means. It just means that it hasn't redshifted yet.
Yeah, and then imagine how many objects that we've determined how many light years away they are. May not actually mean anything.
No, and if we're not considering the initial frequency and wavelength of a star before we make that calculation, then the calculation is completely meaningless. So I don't think we know very much at all about how far things are away from us.
Yeah. Now, the observable universe is 93 billion light years across. That's pretty massive. And they say here that the whole universe is certainly much larger than that. Well, duh, yeah. Because if we can see only to a certain point, I mean, there's no way to gauge how much larger it could be.
Right. Because again, like we discussed earlier, that at a certain point, a star is going to be so far away that it's going to redshift and then the light will go into the spectrum of light that is invisible to us, and then we won't see it. So we don't even know it's there.
Yes,
yeah. So this is the redshift, blue shift concept.
Yeah. It says in 1920, Edwin Hubble discovered something unusual. Some things are moving towards each other and others are moving away. But in a general sense, everything seems to be moving away from everything else around it. So that could explain a couple of things. There could be localized movement in our visible area of the infinite universe where lots of things are repelling each other. But when that concept was actually challenged in recent times, they found it to be more of an average of objects moving in every which way. So there is no real expansion or in any one direction. Things are moving in every direction with no real explanation, except maybe these larger scale, like 100 million light year structures, like the area we're in called Laniakea, which looks like a huge neural network.
Right.
Yeah.
And we're kind of using well, not we, but cosmology has been using the idea of redshift as well to support this idea that things are moving away from us, but it doesn't necessarily mean that. It just means that a star is far enough away that its wavelength has lengthened significantly by the time we see it. That's all it means. It doesn't mean that it's moving away from us. It might be moving towards us. It might be moving away from us, but this is, I'm blown away that this debunking this David Rowland paper about the Redshift Blunder, which was only published in 2021. Like I haven't done any thorough assessment of anybody else writing about this, but how is it that we're only putting this paper out in 2021? I mean, that's crazy. Are scientists really that scared and timid to go against the official narrative? Apparently they are.
Yeah, because there's probably no funding.
Right. And then there goes your career down the toilet. But it's like, my God, it's so frustrating, right? That science is literally being determined by money at the end of the day, like everything else.
It says here in this article that Hubble not only created a paradigm shift from one in which the universe was thought to be fixed and stable to one in which was now expanding, and it appears to be accelerating. And guess how they explain that? Dark matter.
Well, the dark matter particularly is the thing that supposedly prevents the universe from expanding too quickly.
Yeah, so they create an invisible boogeyman to explain something that they can't explain. This is crazy.
Well, so here's what happens, right? So you use these concepts as we've been blunderingly using them for decades now, and then you do the math and you discover that there's some factor that's missing, right? Because the math isn't working. So then you're like, well, this has to be something, right? It's the same thing when we say, oh, whatever that number is, 90 whatever % of matter in the universe it's missing. We don't know where it is. That's the bit in the math that we're like, we don't know what this is. And so then they just make something up. They just made up dark matter, right? And we've spent, I don't even know, like billions of dollars looking for dark matter, and we still haven't found it.
Billions.
Right. It's completely crazy. I mean, so that's the other thing that this David Rowland paper does a great job of explaining, is because of this redshift blunder, it eliminates the need for dark matter, dark energy, black holes, and I think even a finite expanding universe concept.
Yep, expansion theory, Hubble's law goes away, and all the fake things that they created to explain the unexplainable. And when we come back after the break, we're going to be talking about human bias and the dinosaur extinction.
Listen to Revolution Radio at freedomslips.com, and we'll be right back after this message.
Who owns you? If you're not in control, then someone else is. Join me, Ivy West, for Voices on the Wind, Saturday. I discuss government, health, metaphysics, suppressed science, universal mysteries, little-known incredible facts, alternative energies, and even more than you can imagine.
There was blood on the wire.
Won't you join us on Revolution Radio Saturdays for Voices on the Wind with me, Ivy West.
There are lives in the balance, people under fire, children at the cannons.
Because if your head's in the sand, your tail is a target.
Thank you for listening to Revolution Radio at freedomslips.com, the #1 listener-supported radio station on the internet. Please help support this station so this battle can continue forward. Revolution Radio!
The Secret Kindergarten is here for the young children of the world. The best program on the radio for kids, dealing with the most important topics in the whole universe. Fairy tales, music and movement, numbers, plants, animals, fun, colors, insects. Take care and cast your ears out to catch a story from the world of other young things. Reach out, up, under, and over. Sing a song. Talk about feelings. Just remember the magic word. The magic word is no. Step on into the Secret Kindergarten. Saturdays, 1 p.m. to 3 p.m. Eastern Time, right here on Revolution Radio.
Join me on the Brian Ruhe Show on Revolution Radio, Eastern Standard Time, every Tuesday night from 6 to 8. We talk about the four most vital things, in my view, affecting all of humanity. Number one is UFOs and aliens and their agenda for the advancement of humanity. Number two is the Jewish establishment's control over all aspects of human civilization. Number three, the truth about Adolf Hitler, how he was the opposite of what we've been told. Number four is advanced ancient global civilizations. Join me on the Brian Ruhe Show, Tuesday nights from 6 to 8 on Studio B on Revolution Radio.
Thank you for listening to Revolution Radio at freedomslips.com. Any commercial advertising you may hear in this program is of the sole discretion and benefit of the host of whose program you are listening to. Revolution Radio does not endorse any commercial products, nor does it accept monetary compensation for on-air advertising of commercial products, nor will it ever. We are and shall remain 100% listener supported. Any product advertising on this program are considered used at higher risk, and Revolution Radio shall not not be held liable for any claims or damages received from any product advertised within this program. Revolution Radio, where information never sleeps. The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
And we're back with the second half of Cosmic Catastrophe on Revolution.radio, the #1 listener-supported radio on the internets.
You know, I have to admit that the secret kindergarten bumper is really freaking me out now more than the Brian Bruce bumper.
Well, we support free speech, and you can choose to watch any of the programs you wish on Revolution Radio. Now, we discussed in the first half, I believe, a very good point, the major point why cosmology is in crisis. We don't actually know who's coming towards us and away from us or how far anything is away. That's the major problem. We didn't even get into the dirty snowball problem or the accretionary theory of the formation of solar systems. None of that, because it would take hours and hours to dissect the insanity that's going on in cosmology. But let's jump on over to geology, because I think there's an equal amount of problems going on with what they're calling science these days. Now, the paper we're going to talk about is a study that claims it is removing the human bias from the dinosaur debate, but it is filled with human bias, in fact.
It starts with human bias. It's freaking hilarious.
All right, go ahead.
Well,
Go ahead with your thought.
So basically what they did is they took they used I'm just going to read this quote from an article about this paper to begin with, which is this article that we're looking at here on screen. Part of our motivation was to evaluate this question. This is regarding the KPG boundary, the extinction event.
Yeah, so for those that never heard of the KPG event, it's the KT boundary, the extinction of the dinosaurs. They changed the name, God knows why, to be politically correct, I guess.
Well, because they changed the name of the era, right? It's Cretaceous Paleogene is the boundary. It's the boundary between those two eras. Where it used to be,
Paleogene is no longer the tertiary.
Right, exactly. So now it's KPG instead of KT. Okay, so what was the conditions going on when this extinction event happened? So they're looking at that, and they say part of our motivation was to evaluate this question without a predetermined hypothesis or bias. This is Alex Cox, first author of the study and graduate student in Dartmouth's Department of Earth Sciences. Most models move in a forward direction. We adapted a carbon cycle model to run the other way, using the effect to find the cause through statistics. Blah, blah, blah. Okay, you've started with a carbon cycle model. You've started with the assumption that carbon changes climate. There's the human bias right there, right from the get-go. What the heck are they doing? They're treating that theory, because that's all it is a theory, and it's a garbage theory at that, as truth, as absolute truth. That's completely insane. How can you do science like that?
Yeah, it gets worse than that, because in the discussion, they refer to the fact that carbon dioxide affects temperature.
Right.
There is not a single paper, peer-reviewed paper, that shows that anthropogenic global warming, or CO2, warms the Earth. Not one yet. There's not one yet. This is a narrative from the media, from the IPCC, but not from any actual scientific paper.
Yeah. And as we discussed when we interviewed Joe Postma, right, like this is, again, it's the same problem as what was going on with this expanding universe change of theory, right? It's like the math in and of itself is faulty. The model is faulty to begin with, right? And so you have to introduce this other variable to explain the empirical data that you're seeing. In this case, it's introducing the idea of greenhouse gas warming, right? That's the missing chunk that when they do the math incorrectly and they find that something isn't fitting, they're like, oh, well, what's this here? And now we've made it up such that it's carbon. Now we've said it's carbon. So they took 5 different parameters and they plugged it into this model, one of which is sulfur dioxide and the other 4 are carbon related. And they're like, okay, well, we're going to plug it into this model. We're going to run the model backwards and determine what the conditions were that led to extinction. Now, this is another problem with this paper, is that they don't define what the extinction conditions were. Like, we have ideas about what was going on during this extinction event, what caused it, but nothing's definitive, you know? And they don't even define it in this paper. They don't say anything about what the extinction conditions were. They only use the words extinction conditions.
Now I'll discuss the early history of the geology of this boundary. We knew there were dinosaurs. We knew that they ended at a certain place in the geologic record. And so they went out to explore what happened. And what they found was the Deccan Traps.
Right.
They found this gigantic volcanic complex that had been erupting for thousands of years. And then they said, oh, wow, this must have spewed SO4 into the atmosphere. It probably changed the climate. It could have choked the atmosphere. It could have killed plants, or acid rain could have occurred. And then the dinosaurs could have died a slow death. So the original extinction theory was the slow death theory, that it took thousands and thousands of years of these eruptions and this hellish earth to kill the dinosaurs and many other animals at this boundary. But what happened was, in the 90s, they discovered an impact crater, Chicxulub, and then all the proxies in the cores and the rocks coincided with a large impactor on Earth. This is a gigantic impact, which would be catastrophic. At this point, they have the 2-step model, which I believe is what was happening.
Yeah.
We've got the Deccan Traps for thousands of years, making it difficult to live on Earth. And then this giant thing hits, and that's it. It's over. After the impact, it's over. But they want to the only way to get funding is to relook at this another way and blame carbon dioxide. And that's what they've done here.
Yeah. Well, and then worse than that, right? It's like, it goes back to this thing where they only consider 5 different factors, right? 4 of them are carbon related. The other one is sulfur related. And they kind of try to put the Chicxulub impact in that context. And they're like, well, it seems like the impact probably didn't produce that much in terms of those variables. And it's like, okay, well, what about all of the other variables that may have been involved in an impact like this? That's not being considered here at all. And you and I have discussed this on this show. We did a whole show about the Chicxulub impact. And one of the discoveries that we made in reading the literature was that Chicxulub probably crashed into a reef and sent a bunch of calcium and calcium compounds into the atmosphere, which would be white, which would have a major albedo effect, which obviously would have a major impact on life on Earth. So, like, that's just an example of one thing that should be considered when you talk about this event, but it's not addressed here in any way.
The benthic data on this graph shows a rapid several degrees C drop instantaneously around 66 million years ago.
Yeah.
Which would correspond to an impact.
Yes.
Additionally, a Chicxulub-sized impact would darken the skies completely for decades.
Yes.
I mean, the environmental impact of an impact far outweighs the gases or the sulfur dioxide. I mean, that is going to lead to massive climatic shifts, but the impact itself, there's no way to unexplain an impact and be like, oh, the dinosaurs were fine after the impact.
Right. Right. I mean, this paper does acknowledge that the impact probably played a role, but they're kind of downplaying it in one respect because, and I think it's because they really want to highlight their model that they've used and their technique that they've used, and then they're like, well, look, see, we run our model, our thing, and it shows that, these gases increased and blah, blah, blah. And that's what caused the extinction. And then that fits into the current narrative about climate change, et cetera, et cetera. So it's just like, I don't know. Again, it's embarrassing science. I'm not sure what else to say about it.
Well, and it's there are other people doing this on the internets. I mean, they're invoking things that don't need to invoke, like Ben Davidson's micronova.
Mm-hmm.
And I was also listening to Bright Insight, Jimmy, the guy with the who simply stole the Mauritania idea of it being Atlantis from someone else, and everyone thinks he came up with it.
Right.
He was also trying to explain the flooding on the African continent as not being related to an impact. This is just because he hasn't looked into all the scientific literature. So there's lots of people claiming to do scientific research that don't know about what's already in the literature. And you and I discussed this. Like there's no need to have another explanation than an extraterrestrial impactor for the Younger Dryas event. There is a boundary at 12,800 years ago that is loaded with microspherules, iridium, platinum, all the things that come from extraterrestrial sources. And yet people want to deny it or create a different model.
Right. I mean,
it was a micronova.
Yeah. I mean, again, this paper does acknowledge the impact, and it does acknowledge that the evidence of the impact is there. But it still wants to really de-amplify that and amplify everything that was going on with the Deccan traps beforehand. And again, I think it's really just to fit into the way that we're talking about climate change today. Now, I think that if anything, the Deccan traps before the impact probably just essentially amplified the effect of the impacts, right? Because you have a lot of, let's say, particulates in the air just because of the Deccan traps erupting, right? So that's going to have an impact on the amount of light that Earth is receiving, et cetera, et cetera. But it's probably the impact that has the major effect at the end of the day. That's like it's the final nail in the coffin, but maybe it's more than a nail.
Yeah, and the conclusions of the paper are pretty wishy-washy.
Yeah. Well, I mean, I don't even know if they really even have a conclusion, except to say their conclusion is essentially like, look, our model, our method here is really useful. We should use it for a bunch of other things. That's basically what their conclusion is. But I mean, this claim that this is removing the bias from this science is it's so faulty to make that claim. And it's precisely because it's starts with a carbon cycle model to begin with.
Yeah, and the inputs they use are all based on human bias.
Right. The inputs are you based on the idea that carbon dioxide is a greenhouse gas that causes heating.
So this study did not remove human bias from the debate over the dinosaurs. It relied on it.
Right. Well, and they're saying this, right, only because they allowed a computer to run these models, right? And it is kind of cool in a way, right? Because you can throw a huge amount of information into something like this and let the computer do the calculation, whereas for a human being, it might take an incredibly long time to do that work. Like, that is cool. But if you can't acknowledge that the initial inputs that you put in are the result of human bias, you have a real problem.
Yeah, exactly. And a lot of people are trying to fit their hypothesis into the data when the data doesn't actually fit. Yeah. So that's the problem.
And that's interesting, right? I was thinking about this last week because this is something that we've kind of seen happen, right? We have theories about climate change, and then in reality, the empirical data doesn't fit that well. And what is the result of that is we've seen the data being manipulated. We've seen graphs, right, that where the temperatures are actually manipulated and not the same as what they were, let's say, 2 decades ago.
Yeah.
Tony Heller on Twitter and elsewhere does a great job of illustrating those manipulations that have occurred. If you've never checked him out, it's worth checking him out.
Yeah. I want to talk about some false realities that people have before we end the show here. There are a lot of people on the internets that are spewing this 12,000 year cycle nonsense.
Yeah.
And it has to do with pole shift, that there's a pole shift every 12,000 years. Now, this was actually a magnetic pole shift, not the rotational pole. So let's get that straight. But there is no 12,000 year cycle of geomagnetic excursion at all. When you look at the data here, we're looking at the last three. Okay, so the top graph here is the last 45,000 years. And down here, we go all the way to 300,000 years ago. And if in the top graph, we can easily see that the magnetic field strength is fluctuating here over a period of about 6,000 years, and then a shorter cycle of 4,000 years, and then a 1,000-year cycle here, then a 2,000-year cycle, and then a bigger cycle here that's like 8,000 years. There is no repetitive time frame of the shifting of the geomagnetic field of Earth. None.
Yeah. Yep.
And the major ones that we even that there are peer-reviewed studies on, like the Lechamp and the Mono Lake, and this one here and the Blake, none of them are separated by 12,000 years or any regular periodic time frame.
No.
So from Mono Lake to Lechamp is 2, 4, 6,000 years. From the Lechamp to the Blake is about 11,000 years. And then from Blake to Blake is 4,000 years. There's no cycle.
Yep. There's no regularity of time between pole shifts or magnetic shifts or magnetic excursions. It's not there.
No, it's kind of it's very random.
Yes. Yeah, it is random.
And
so I don't
understand.
I don't understand why someone would espouse that it's on a regular cycle. I don't understand that. I mean, perhaps it's just that is a very digestible idea or an appealing idea, and that people easily buy into that.
Well, people want to believe in a clock cycle. They want to believe in the great year, which probably does exist. But I've delved into the data, the ice core data, all the proxy data we have, then there's almost no way to fit the great year into the data. There is a slight fit. It may correspond, but there's a high variability in the periodicity. It isn't a clock cycle. And another thing happens, Randall Carlson came up with the idea of the clock cycle in the form of the Iron Cross with the Great Year. The events that occur actually on the 6,000 year periodicity are not all geomagnetic. They're also climatic.
Right.
So you have to look at a multiplicity of data to actually fit the clock cycle. I think the clock cycle is true, but it is not directly related to the geomagnetic field. It's related to other things as well.
Well, I mean, here's why it gets complicated, right? Because any kind of shift in the magnetics is going to also be related to climate. So you've got one variable building on another. One thing shifts, and then things shift in this other arena. So that makes it this very organic phenomena. You know, it's like, this is a weird analogy, but it's like the difference between having a subway system that you've planned out ahead of time and is very regular and organized, like something like the Washington, D.C. system, versus like the New York City system, which is completely organic and various branches cropped up at need. Like one of these is systematic and arranged ahead of time, and one of them is just like a reaction to the specific things that are actually happening in the world.
Yeah. So what do we do?
Well, we just keep talking about the real data.
Yeah, we keep showing the data. You just keep showing the data. And here's some of the data that we need to show. This is the position of Agenda 2030 and all of the 15-minute cities that are being planned.
Are these the C40 cities?
You got them.
Yeah.
And you can see in the four corners, there are none.
Yeah.
But it looks like Grand Junction.
Certainly Denver.
And Denver.
Yeah.
Colorado Springs to the south. And this, I don't know what this may be, Pueblo.
Oh dear. Yeah, it could be. Yeah.
So, but what you should glean from this is east of the Mississippi is highly concentrated in these 15-minute cities. If you're stuck east of the Mississippi when Agenda 2030 occurs, you may not be able to go anywhere.
Where did you get this map from?
It just came out. If you just put 15-minute cities map in your Google box, you'll be able to find the image and the article.
It's interesting because as I've been sort of following this, C40 cities. So the C40 cities are the cities that are basically committing to implement a variety of conditions, right? Like less meat eating by, a specific amount of less meat eating by a certain year. And, you can only buy certain numbers, items of clothing by this year, et cetera, et cetera. Anyway, but they only ever list like maybe 15 cities that are participating in this. But this map illustrates that apparently there's quite a lot more than that.
Yeah, and herein lies the problem. If we get rid of physical money and convert everything to digital, there will be a control mechanism in these areas, and all the things you just said will occur. So let's say you're in one of these cities and you can only eat 3 pounds of meat a month, and you want a burger and you've already reached your limit. There will be no place that you could buy the burger. It won't be allowed with your digital currency.
Right, exactly.
If you've traveled your allotted 50 miles for the week, you won't be allowed to go on vacation.
Mm-hmm.
Yeah, so these are the types of things that people need to consider. This type of control is extremely dangerous. And, I don't, what type of, because at this point we're going to have robotic dogs that are going to be the police force.
Right.
Because no human is going to want to enforce this kind of garbage when people go against it.
Right. And I was about to say, because of that, I mean, this map clearly shows that the interest in implementing this is, at least for the moment, relegated to high population areas, right? You cannot enforce this kind of stuff in a rural area like where we live. Like, it's just not going to happen.
Yeah, there has to be infrastructure and stuff that everyone needs within 5 miles.
Right.
That certainly doesn't happen out here.
Right. Well, I mean, I suppose what you could do is let's say if you very specifically had a lot of travel restrictions, you could make it impossible to live in a place like we do, right? We're about 20 miles from the grocery store. So, if you implement those travel restrictions, you make it impossible for people to go to the grocery store. Well, some people will leave. They'll move to a higher population area. But of course, your other option is to do what we're doing and grow your own food and say, screw it to all of this garbage.
Yeah. So I think that the big fight that's happening now in the next few years is trying to keep actual cash a thing to prevent this transition to digital currency in the United States, because that is the biggest control mechanism. We're talking like the Patriot Act times 1,000,000 once we go digital.
Yes. I mean, our lifetimes have been, or I'll just say our adulthoods have been very interesting, right? Living through 9/11 and everything that came out of that in terms of security theater, and everything that's happened in the last 3 years is the same security theater, but on steroids.
Yeah, and they're already implementing this in the UK. I was on the Twitter this morning, or the X, and there are people sharing photographs. They're clear cutting all the trees in the inner cities to put up the cameras for facial recognition.
Oh my God.
So in these 15-minute cities, they're going to know if you jaywalk, you will get a fine that automatically deducts the money from your bank account. There will be no judge, no jury. It will just be implemented.
Yeah. And
it literally is 1984 and Big Brother, and it's coming in the next few years, and it's ramping up.
And it's not like the technology and the precedent isn't there, right? We've already seen this happen in China. And then you've got people like Justin Trudeau, who talks about how much he admires China, like basically for the control that it has over its population. And it's through this kind of system.
Yeah. So, and where do you think they're getting the systems in the UK? They didn't develop it themselves. They got it from the ones that are already developed in China.
Right. Well, why reinvent the wheel? If this is really what you want to do, then that's the easiest way to do it, is copy what China did and use their technology.
Yeah, we really need to prevent this from happening. But unfortunately, if you guys didn't watch the 4-way conversation on transhumanism and disinformation and climate fear-mongering, I implore you to go watch that. We'll link it below here after the show. because I suggested that what's going to happen in the next 5 or 10 years is a split of humanity where there will be a group of us that want to still be humans, and there'll be a whole other group that want to be transhuman. And I don't mean transgender, but they'll certainly be part of the transhuman movement. I'm talking about people with computer chips in their head that are in the matrix, that are fed through tubes, that live in these smart cities, that want to be controlled, while a group of us want absolutely nothing to do with it.
Yeah. And as we discussed in that show that you just mentioned, I mean, there's already a huge split amongst people in terms of what they believe about the world and what's actually going on, whether it's regarding globalist agendas or climate change or whatever. And this has been achieved by divisiveness in the media and in government, by vilifying the other guy all the time. And so that has made conversation quite difficult.
Will you take the blue pill or will you take the red one? Thanks for listening. Be safe. We love you.
Listen to Revolution Radio at freedomslips.com, and we'll be right back after this message.